everyone, I am Sanskriti Jadhav from T.Y.B.Sc Physics from Changu Kana Thakur ACS College Autonomous. Today we are going to study about the topic semiconductors. And here's the index which we are going to study today. Now what exactly are semiconductors? Semiconductors are chameleons of the electric world. As chameleons change color, semiconductor changes its conductivity due to temperature and voltage. Now, India is gearing up to set up new factories of semiconductors, which are Vedanta Foxconn joint venture in Dholera, Gujarat, Micron Technology in Sanand, Gujarat, Reliance Semiconductor in Navi Mumbai, Maharashtra, and Tata Electronics in Krishnanagari, Tamil Nadu. Now let us differentiate conductor, semiconductor and insulator. Conductors are the materials which allow the flow of electrons. Example, copper, steel, gold, aluminium. Semiconductors are the materials which have conductivity between conductors and insulators. Example, silicon and germanium. Insulators are the materials which oppose the flow of electrons. Example, plastic, wood, rubber. Let us study the history of semiconductors. How did we went from CRT TVs to LED TVs? Earlier, we used vacuum tube instead of semiconductors in CRT TVs. Vacuum tube consists of three main components: cathode, control grid, and anode. In which these three components are enclosed in a glass tube in which the cathode is heated up and electrons are flowed towards the anode, and the control gate controls the flow of electrons. Why did we change from vacuum tubes to semiconductors? As vacuum tubes are very large in size and semiconductors are very small in size, and the cathode in the vacuum tubes get degraded easily, due to which the lifespan of vacuum tube is very less and the semiconductor lasts very long. The next topic is our energy band. Now let us study about the valence band and conduction band. What is valence band? Valence band consists of the valence electron, and the conduction band consists of the electrons which are passed from valence band to conduction band. In conductors, the valence band and conduction band do not have energy gap between them. In semiconductors, it have the energy gap greater than conductor and less than insulator. In insulators, the energy gap is much higher than semiconductors, due to which electrons could not pass through conduction band. Types of semiconductor: intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are pure form of semiconductor made up of silicon and germanium. Extrinsic semiconductors are of two types, N type and P type. Now what are extrinsic semiconductors? Extrinsic semiconductors are impure semiconductors which are done by doping. What is doping? The doping is the process uh, of adding some impurity atom in a pure or an intrinsic semiconductor so as to increase the conductivity of a semiconductor. In intrinsic semiconductor, as given in a figure 1, at 0 Kelvin the silicon bonding is shown and with a covalent bonding. In the second figure, at moderate temperature, free electron is generated and hole is created. This process continues, due to which the conductivity increases. In extrinsic semiconductor, there are two types. First, N type semiconductor. N type semiconductor, pentavalent impurities added. In N type semiconductor, number of electrons are greater than number of holes. Example, phosphorus and arsenic. In p-type semiconductor, trivalent impurity is added to p-type semiconductors. Number of holes are greater than number of electrons. Example, aluminium. in PN, what is PN junction? PN junction means P and N type semiconductors are connected to each other. And what is PN junction diode? When P and N type semiconductors are joined together, the holes from the P side and the electrons from the N side move towards the junction and form a neutral layer or a depletion layer, which is called as PN junction diode. Now, what is forward bias? The positive terminal of the power supply is connected to the P side, the negative terminal is connected to the N side. The electrons in the N side gain energy from the negative terminal and move towards the junction. Once they cross the junction into the P side, they recombine with the holes. Holes in the P side are pushed towards the junction, the positive terminal, by the positive terminal. Once they cross into the N side, they recombine with the electrons. The applied voltage reduces the potential barrier created by the depletion layer. This makes it easier for electrons and holes to move across the junction. As the voltage continues to increase, electrons and holes have enough energy to cross the junction. This results in a significant current flow through the diode, indicating conduction. Now, what is reverse biasing? The positive terminal of the power supply is connected to the N side, the negative terminal is connected to the P side, and as a N side is connected to the positive terminal, electrons are attracted. As electrons move, holes are generated. As P side is connected to the negative terminal, due to which holes are filled. As a result of this, the width of the depletion layer increases and no more holes or electrons cross the junction, due to which the resistance is high and no current can pass through. What are rectifiers? An electronic circuit which rectifies AC voltage to DC voltage is called as rectifiers. Rectifiers are used in chargers of mobile phones and laptops, as the battery of the laptops and mobile phones requires DC supply. Rectifiers are of two types: half wave rectifier and full wave rectifier. First is the half wave rectifier. In half wave rectifier, one diode is used to convert AC signal to the DC signal, and in full wave rectifier, two diodes are used to convert AC signal to DC signal. Thank you.